Yeah, but you can let it run separately. That doesn't make them hard.
It's like two chords.
Oh.
Okay.
The mouth is big. It couldn't even open the eyes. I was like, there's no way I'm letting you kill the mom. Sweetie baby. One minute I'm not grabbing.
You know you're only supposed to do like one thing about like.
What you might want to do is to, since we're going to be graphing and we're going to be evaluating a lot of trigonometry today, you may want to draw your reference triangles for yourselves. Okay, I'll put them up here on the board too, so we can have them to refer to.
Maybe it's not true.
Okay. So you might want to have this for yourself, okay, because we're going to be evaluating a lot of trigonometry today. So like, good review for some of the things that we haven't seen for a while. And I guess maybe okay. So again, we have to kind of like recalibrate our brains a little bit here about how we graph things, right? So the first thing I'm going to have us graph is actually going to be super easy. All right, we're going to graph. So when we graph graphing polar equations here, we'll call this. Okay. Typically, okay, it's a little bit backwards, first of all. So for those of you that, maybe just review from yesterday real quick, r comma theta, okay, we still use two numbers here to identify any location in the coordinate plane, okay? The idea behind polar coordinates, though, different than xy coordinates, instead of going left, right, up and down from the origin, okay, we instead open up a certain angle theta from our polar axis here, so like basically like the x-axis, we open up a certain angle, and then we go out a certain distance from the pole, and that's how we locate a point, okay? That's how we locate a point here. And so we just graphed coordinates yesterday, but today we're going to actually relate r and theta using an equation, okay? Also kind of different from how we do things with rectangular coordinates. Normally, right, with rectangular coordinates, we have like this is like our y, right? So this is like our dependent variable, and this is like our independent variable. And in fact, these relationships, or this role is flip-flopped for polar coordinates. Okay. Theta actually is our independent variable. We treat it like our independent variable, and r is like our dependent variable. So in other words, all of our equations are going to be like r equals stuff with theta. Okay. So for our first equation here, we'll do a very simple one. We'll just say, let's graph r equals 8, for example. Okay. Let's just graph r equals 8. Question. Oh, you need a piece. Can Abby? Oh, what? You need a sheet of paper, right? Thank you, Abby. Okay. So let's think about what this is going to look like. Again, when we started graphing things, way back when we first started graphing things, we made a table of values. So we'll do the same thing here. Okay. We'll pick some thetas, and then we'll figure out the matching r values here. Okay. But of course, no matter what theta values we pick, what will our r values be? 8, right? So I can pick like 0. I could pick like pi over 6. I could pick pi over 2. I could pick the number 3. Okay. Yes, you can evaluate a theta value of 3, right? It's not one of our typical ones. We would need to do it with a calculator. But in this case, all the r values are going to be 8. Okay? So if I were to try and graph this, so let's see here, theta of 0, r value of 8. So here's 0, right? And so I'll go out 8. So 1, 2, 3, 4, 5, 6, 7, 8. It's at the very end of our circle there. Again, if we count all these as 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so there's a point. Let's see here, pi over 6, 8. So again, pi over 6, and I'll just count 8 rings. 1, 2, 3, 4, 5, 6, 7, 8. Oh, we're still on the edge there. Pi over 2 equals 8. And then 3, well, 3 is a little bit less than pi, so I don't know, it'll be something like right in there maybe, or something like that. Okay. And so, of course, any angle that we put in, any theta value we plug in, we're going to get an r value of 8. So what kind of shape will this create? A circle with radius 8. Yeah, it's just a circle with radius 8. Okay. So this is kind of like, you know, graphing the line like y equals 3. This is like the equivalent of graphing a horizontal line in polar coordinates. It's just a circle. Okay, so that wasn't very special. That's too easy, Mr. Widmeyer. Okay. Let's try r equals, Matt and Noah, guys, keep it on topic. R equals 4 sine theta. Okay? So, we'll pick some theta values, plug them in, and then get some matching r values. And here is where things are going to get a little bit interesting, because we know that when you take sine of a particular angle, it's going to change along with that theta. So as theta changes, your sine of that theta is going to change, and then 4 times that is also going to change here. Okay? So, let's see what we get here. And we'll start, again, at 0 and kind of make our way around. We pick, 0, pi over 6, pi over 4, pi over 3, because those are easy, in air quotes, easy, quick ways for us to calculate sine, right? I mean, if we had our calculators, we could pick any theta value we wanted here. We could pick, 1, 2, 3, 4, 5, 6. We could pick, decimals, whatever we wanted. But since we're trying to do this without a calculator here, we're going to pick some typical ones. So we'll start with 0, and then do like pi over 6, then pi over 4, and then pi over 3. Okay? All right, so sine of 0 is what? 0 times 4. 0. Okay. Sine of pi over 6. 1/2 times 4, though. 2. Okay. Sine of pi over 4. Root 2 over 2, which then times 4 will be 2 root 2. Okay. And then pi over 3. Sine of pi over 3. Yeah, so root 3 over 2, but then times 4, it's going to be 2 root 3. Okay? All right, so let's go ahead and let's just hold on. Actually, let's go one more. Let's do the pi over 2, since pi over 2 is right there at the top. Okay? What's sine of pi over 2? 1, but then times 4, it's going to be 4. All right, so now let's plot this. I'm going to do this in a different color here just to kind of keep it, well, hopefully it'll show up. Let's see. Okay, so we got the point 0, 0. So at 0 degrees, we're going to have a radius of 0. So that means we're right at the pole for that first point, right at the pole. Okay, then the next one, we've got pi over 6, and we're going to go out 2. Okay, that's pretty easy to do, right? There's the angle pi over 6, and we'll go out 2 from the pole. So 1, 2, there's our point. And then pi over 4, 2 root 2. Now this is, we're going to have to cheat a little bit here because, 2 root 2 is not easy for us to graph without knowing what the decimal is there. So it's about 2.8. About 2.8. So at pi over 4, we're going to count out almost 3 rings, right? We're going to go out almost 3. So 1, 2, and so then here would be 3, but we want to go less than that. We want to go 2.8, so maybe like right there. And then pi over 3, well, that's 2 root 3, so let's see, 2 square roots of 3. We can go ahead and say that's just about 3.5, 3.5. So in the pi over 3 direction, we'll go out just about 3.5. So 1, 2, 3, there's 3.5, so just a little bit shy of that, I'll put a point right there. Okay, interesting. Is he going to make a circle? A what? A swirl? We'll see. A swirl. There are ways to do swirls, there are ways to do circles, so we'll see here. It is kind of curving back on itself, though, isn't it? It is curving back on itself, so we'll see here. All right, then we'll do pi over 2. Pi over 2, 4. 1, 2, 3, 4. Okay? Interesting. So now we want to connect these in order. So it looks like we try and connect these, we're going to get something like that. Now, here's where the more comfortable we are with our sine and cosine and tangent relationships, the easier these problems will become. When I go to the next quadrant, quadrant 2 there, for example, 2 pi over 3. Sine of 2 pi over 3 is what value? What's the sine of 2 pi over 3? Well, the sine of pi over 3 is root 3 over 2, and since sine is positive in that in the second quadrant as well, it'll still be that root 3 over 2. So in other words, sine will have the same value. The angles in the first quadrant and the angles in the second quadrant for sine have the same values, right? Because they're both positive there. And so in other words, all of these r values are going to repeat. All these r values are going to repeat for their quadrant 2 angles. So for example, 2 root 3 is true for pi over 3. It's also going to be true for 2 pi over 3. Because 2 pi over 3, sine of 2 pi over 3 is also going to give you root 3 over 2, which then multiplies by 4 to give you 2 root 3. Okay. Pi over 4, that's going to give us the same angle as 3 pi over 4. And then pi over 6 is also going to be 5 pi over 6. Okay? So going out to 2 pi over 3, towards 2 pi over 3, we only need to go out 2 root 3 again. So remember that 2 root 3 was about 3.5. 3.5 there. So 1, 2, 3.5. So a little bit short of 3.5 right there, we'll say. Okay. And then 3 pi over 4. Again, it's the same as the pi over 4, so we're going to go out 2 root 2, which the 2 root 2 is about 2.8. So towards the 3 pi over 4, about 2.8. So 1, 2, there's 3, so a little bit short of that. Okay. And then the 5 pi over 6 goes towards the the 5 pi over 6, 2. So 1, 2, 5 pi over 6. Okay. And then let's go ahead and do pi as well, since, we didn't talk about pi. What's the sine of pi? 0 times 4 is still 0. So it's just like evaluating the 0 again. So we're back to the 0. So if we now connect the dots, so what kind of shape does it look like we have here? It looks like a circle. It is, in fact, a circle. It is, in fact, a circle. Okay. What is the radius of this circle? Is it a radius of 4? The radius, yeah. So let's see here. So if we think about it this way, right? This is a nice vertical direction here. The radius length from this point to this point is a radius length of 4, right? The radius from the pole. But if you consider the thing as a circle, the center of the circle is right here, and its radius is what? 2. So the radius of the circle we get is 2, which is just half of that 4 there.
Is it going to make an 8?
So, good question. Let's check out. Let's see what happens then as we go. So let's go to 7 pi over 6. Okay?
I put my paper backwards.
You put your paper backwards?
Actually,
Upside down? Okay, well, that's not a problem. You can just, change all the angles if you want to or something like that, yeah. So now let's try the 7 pi over 6. Why are the numbers upside down? Yeah. I just figured this was not easy. This was too easy for you guys. I figured we'll just put the numbers upside down for you, too, to make it even more challenging. Yeah. All right, so 7 pi over 6, okay, that's the same as the pi over 6. Oh, so that's your time, guys. Are you done?
Yeah.
Okay. You've been done for a while now?
I thought it was my turn.
Okay. So you can move on now to the non-calculated section.
Dang, it didn't turn off my alarm.
So you can turn on. So you just did that one. All right. Okay, that's fine. So you're done then, Kate?
Yes, my last.
Okay. So there you go. You got it. All right. Well then, I'll just.
I got your breath.
Yeah.
Unless you guys.
What?
They should have to take it off.
Take a sec. You can go back to your seat if you want, or you can hang back there if you want, whatever. I do. Yes.
Well, counselor.
Sure.
Extra work. So she needs one off. So I can not take it.
Okay.
Oh, was it changed? What was that?
Okay. So yeah, let's see what happens when we keep going here. So let's think about, I'm going to go back to my, let's think about, and let's go to 7 pi over 6 now. Okay, so, excuse me. What is the sine of 7 pi over 6? Sine of 7 pi over 6 is negative 1/2. Okay, so now, so pi over 6, we were getting 1/2. 5 pi over 6, we got 1/2. 7 pi over 6, we're now negative 1/2 because we're in that third quadrant. So the only thing that's changed is the sign, S-I-G-N, whether it's positive or negative. Okay, so then we're going to take that negative 1/2, multiply by 2, or sorry, multiply by 4, and now we're at negative 2. So we get 7 pi over 6, negative 2. So when I go to graph 7 pi over 6, so I'm going to open up there 7 pi over 6, we're going to go towards that 7 pi over 6, except we're not going to go towards it, we're going to go the opposite direction. What's the exact opposite direction of 7 pi over 6? Pi over 6, and we're going to go 2 in that direction. Ready for this? 1, 2, it's the same point. Okay? Guess what happens at 5 pi over 4?
Wait, why isn't it negative?
It is negative, so it's just going to repeat the circle, yeah, as you go from 0 to 2 pi. Okay, so it just repeats the circle because it goes backwards. So 7 pi over 6, we're going to go back 2. At 5 pi over 4, we're actually going to go back 2 root 2 to get to that point. At 4 pi over 3, we're going to go back 2 root 3. At 3 pi over 2, we're going to go back 4 to get to that, and so it actually ends up repeating. Okay, ends up just repeating the circle. So we're done with the graph here. The same thing will happen in quadrant 4. They'll just go back. 11 pi over 6. Okay, you're going to end up with a negative 2, so it just goes back 2 from the 11 pi over 6. So you essentially just do the circle twice, okay, if you do all from 0 to 2 pi. It just repeats itself. So it's a circle, okay? So that you can maybe guess, how might we be able to adjust this, right? So let's say, for example, I wanted to increase the radius of this circle to be a radius of not 2, I want the radius of the circle to be 3. How do you think we should maybe adjust our equation here? Make it 6. So let's just see here. I'll do it in the graphing calculator just to make it quicker. Okay. So let's see here. 6 sine of theta. Okay. There's our circle. And if you look here, we can count. I'll try to zoom in some. Okay. You can count here. It's got a radius of 1, 2, 3, 4, 5, 6. Or sorry, radius of 6. Diameter of 6. So the radius would be 3. So yes, good job there. Okay. You just double the radius, and that gives you that circle. All right. What happens if we did cosine? What kind of shape would you guys expect for 4 cosine? What kind of shape would you expect? What do you think? You want to make a prediction? Remember, sine and cosine are very similar, right? It'll be a circle, but just in a different location. In fact, there's cosine. There's 4 cosine of theta. Okay, it's going to be on the x-coordinate. That's all. Okay. And it has the same kind of relationship. If I want it to be, radius of 3, I just make it 6 for the number in front there. If I want the circle to be on the other side, what do you think we should do? Make it negative, yeah. So let's just, let me fix that. So, and voila, you're right. Okay, yeah, there it is. And so if you want, you could do all sorts of fun little things here. If you wanted to, you could do then, I don't know, 6 sine of theta and make little designs and things. But anyway, so there's that. Okay. So let's try another thing, though. We've kind of figured that one out. We've done what we can with that. So let's try another one. All right. Let's try r equals 1 minus 3 times the sine of theta. Okay, 1 minus 3 times the sine of theta. So here we have not only some multiplication, but also some subtraction stuff too. So this is going to affect things as well. Okay. 1 minus 3 times the sine of theta. Okay. All right. So let's make another table here. we'll start with 0. Okay, so sine of 0, 0 times 3, 0, but 1 minus 0, 1. Okay, let's do pi over 6. Okay, pi over 6, so sine of pi over 6 is 1/2, that's right, sine of pi over 6 is 1/2, and then 3 times 1/2, 3/2, and then 1 minus 3/2, negative 1/2. Okay, then we have pi over 4. That's the next one. Okay, sine of pi over 4 is root 2 over 2. 3 times root 2 over 2, a decimal, and then 1 minus, so we're going to have basically 1 minus 3 root 2 over 2, whatever that is. That's a decimal. Pi over 3 also is going to be kind of yucky. Sine of pi over 3 is root 3 over 2 times 3, so it will be 1 minus 3 square root of 3 over 2. Again, not that great. Kind of hard to graph. But then we can do pi over 2. What's the sine of pi over 2? 1. So 3 times 1 is 3. 1 minus 3 is negative 2. Okay? So let's plot these points here. So let's see here. So we start with 0, 0, 1. So with a radius of 0, sorry, not radius of 0, an angle of 0, we're going to go out 1, so to right here. So there's our very first point. Okay. And then our very next point, pi over 6, we're going to kind of angle ourselves like we're going to go towards that pi over 6, but because it's a negative 1/2 r, we're not going to go towards the pi over 6, we're going to go the opposite direction towards 7 pi over 6. And we're going to go 1/2, so that means there's negative 1, so we're going to go halfway out. So it's like right there, we'll say. Okay, so right there. Now, here's another thing we have to keep in mind. Again, when we go to graph this, we're going to be graphing kind of like all the angles between 0 and pi over 6, right? That's like when we're connecting the dots, we graph from here to here, right? We connected all the angles from 0 to pi over 6 to get from this dot to this dot right here. To get from 0 to pi over 6, our r values start at 1 and go to negative 1/2. So what specific number are we going to have to go through for our r values to go from 1 to negative 1/2? What r value can we say we're going to have to go through? If we start at 1 for an r value and we have to go from 1 down to negative 1/2, what particular value are we definitely going to hit? 0, for example, yeah, and all the numbers in between, but 0 the big one. So in other words, from when we start tracing from this point to this point, I have to go through an r value of 0, which means I have to go through the pole. So I'm also going to if you want to start connecting the dots, you can here, but we're going to kind of go through the pole like this to get to this other point right here. We have to touch that pole at some point there. But anyway, let's keep going. I'm not going to worry about these 2 points. I'm going to see if I can maybe try and figure out. So then at pi over 2, we're at negative 2. So pi over 2, that's the pi over 2 direction. We're at negative 2. So negative 1, 2, this point right here. So in order to kind of get from where we are here down to here, we're going to have to kind of like loop around like this. Okay. So again, why am I skipping these other 2 points? Just because if we were doing this without a calculator, right, we wouldn't really know off the top of our heads what 1 minus 3 root 2 over 2 is, or what 1 minus 3 root 3 over 2 is. But knowing the points that we do know, we can still kind of get an idea of how this graph is going to look, how it's got to kind of curve around. Okay. So now we'll do the same thing, except we'll use these second quadrant angles. But of course, since we're still using sine, that means these second quadrant angles are going to still match, right? The first and second quadrant for sine are going to yield the same r values. First and second quadrant, because sine doesn't change. It's still positive in that first and second quadrant. So for example, at 2 pi over 3, we're going to be at the pi over 3. There's still the same idea as pi over 3 there. So 2 pi over 3 will be that, which again is not super helpful because it's a decimal. This will be 3 pi over 4 will be the same thing here. And then here we have 5 pi over 6, which is finally something we can actually use, the negative 1/2. So at 5 pi over 6, we're not going to go towards it. We'll go away 1/2. So something like there. And so again, you can kind of see, okay, well, we looped around this way. Look, we're going to have to like loop back around this way. Okay. And let's go ahead and do pi as well. So at pi, okay, sine of pi is 0 times 3 is still 0, and then 1 minus 0 is 1. So we have pi comma 1. So at the angle of pi, we're going to go out 1, so to right there. Okay. And again, we're going from an r value of negative 1/2 here to a positive r value of positive 1. So we have to go back through that pole again, too. Since we're going from an r value of negative 1/2 back to 1, we're going to look something like that. Okay, so the graph has intersected itself. Kind of weird, but there it is. All right, and then all of these values down here, well, now we have to be careful because now sine is negative, which is going to affect things. So let's take a look at that third quadrant, and we can use the third quadrant to get the fourth quadrant too. So we got 7 pi over 6. What's sine of 7 pi over 6? Negative 1/2, but then times negative 3 becomes positive 3/2. 3/2 plus 1, 5/2. Or 2.5 if you want to say it that way. Okay, I'm going to skip the pi over 4 and the pi over 3 because we know those pi over 4 and pi over 3s are going to have the square roots in them, and that's not very helpful. So I'll kind of skip those. Hopefully we'll still be able to kind of figure out what the graph looks like. So we'll skip the pi over 4 and the pi over 3. We're going to go right down to the 3 pi over 2. What's sine of 3 pi over 2? Negative 1. Negative 1 times negative 3 is positive 3, plus 1 is 4. Okay. So let's try and graph this then. We got 7 pi over 6. We're going to go out 5/2 or 2.5. So 1, 2.5. So right there. And then 3 pi over 2 to 4. So here's 3 pi over 2. So 1, 2, 3, 4. Point right there. And so you can kind of see how we have to go. We'll have to go kind of like around like that. Okay. And then because sine is negative in the third quadrant and the fourth quadrant, we can use the same kind of angles here. So again, 5 pi over 3 is not going to be helpful. We'll have square roots in them. 7 pi over 4 not going to be helpful. We're going to have a square root. But 11 pi over 6 is going to be the same as 7 pi over 6. And so we can go 2.5 towards that 11 pi over 6. So 1, 2.5. There's that point, and then we can finish connecting that around like that. And then we'll get to 2 pi, which is the same as 0, and so we know we go back to the 1 there. And we're done. We've created our graph. All right. I think that's called a cardioid. Cardioid, because it's supposed to kind of look like a heart. All right. And in fact, if we graph this, there's kind of the graph there. I don't know. I didn't go far enough down in the window. Okay, there it is. That's what we've got. Okay. All right. So, question? Yes, go ahead. All right. So, any questions on any of that? All right. I think I kind of want to let you guys get started on things here. Okay. So I might just have you do that. Yeah. Maybe we'll do that. Okay. So I'll just do that again. So I'll give you guys an opportunity to try some of these here. So for your assignment, okay, just so that way you guys have some time, I'll stop right here. Okay. I have 4 graphs for you that I would like you to do. On page 789, I want you to do numbers 23, 28, 29, and 33. Okay? So what I would like you to do is, again, make these tables of values. Try and use symmetry, right? Sine, for example, we know the first and second quadrants, those angles in the first and second quadrant should have the same R value. And in the third and fourth quadrant, sine has the R values the same. If we were doing cosine, what pairs of quadrants would be the same? First and fourth. So these right two, okay, you can count on the cosine angle to be the same, and then the third and the second one, cosine angle will be the same there, which will be the negative versions. Okay? So you can use that to your advantage to help you there. Okay? And also feel free to skip some of these weird radical ones, right? With like the 3 root 2 over 2, the 3 root 3 over 2. Skip those if you can. Try just graphing the points whose values you know precisely, right? So like the -1/2, the -2, the 1 there, and that kind of stuff. And see if you can get, again, just sketch them in order, graph in order, and try and just connect them to get those curves. Okay? Alright. Again, for those of you that are planning on taking AB next year and just year-long AB, you won't have to worry about seeing this ever again. This is it for it, okay? If you're planning on taking ABBC next year, this will show up here, okay? Not so much the graphing by hand part, but definitely like what we did yesterday with like to the converting between, you know, a rectangular and polar and stuff like that for sure. But this will show up again too though for sure in calculus, okay? If you take Calc 1 and 2, okay? So, there's that. And it's also looking quite possible, more likely now that I will be teaching an ABBC section. It looks like there's going to be 3 ABBC sections. So it'll be Mr. Goff teaching 2 and me teaching 1.
Are you gonna teach it like year long the whole year?
I'll be having it the whole year, yeah. So how that'll work then is that halfway through the year, some students will swap from Goff to me or from me to Goff kind of thing. Like we won't have the same students throughout the whole time.
Mr. Umar, are we
But
collecting warm-ups?
yes, so Abby, if you don't mind, Abby, come around and get the warm up. Okay.
Yeah,